So I noticed after grading section 8.1 and 8.2, we're struggling with graphing the trig functions. Some people didn't graph any of them at all, so I'm just going to cover that because that's going to be a large portion of the exam. So I'm going to give an example, I'm going to show you how I graph it and what you're going to be expected to essentially do on the exam. So let's say we have y, just make it f of x. F of x is equal to 2 sine of pi x plus 1, for instance. Let's say this is the graph that we need to do. We're going to use a table to start, and the x, y values, remember that f of x is just y, that we're going to use are going to be from the unit circle. And for sine, we're going to use the poles. And so what I mean by the poles is kind of like northeast, southwest. So we're going to use 0, we're going to use pi over 2, we're going to use pi, 3 pi over 2, and 2 pi. So we're going to use this one twice. So the x's are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, cool. So the technique that we're using, all it really uses is the fact that you kind of already understand that the sine graph kind of looks something like this. So if you understand that the sine graph looks like this, then you're able to use this technique. The first point here, that red point, that's 0, 0. The second red point, that happens at pi over 2, because that's our maximum, so we get 1 there. The next point happens at pi, because sine of pi is 0. The next point here, this is 3 pi over 2, and sine is -1 here. And once again, sine of 2 pi, which is the same as sine of 0, this is also going to be 0. And so that's one period of pi. Basically, we start at the intersection, we go to our maximum, go through the x-axis again, go to our minimum, and then start back over. So if we were to draw another period, sine basically just repeats itself, kind of like this. That would be 2 periods of pi. Okay, so now that we know what the regular sine graph looks like, this is just the parent function. So what I've drawn here, this graph right here, is actually f of x is equal to regular sine of x with no other numbers included. So what we need to do now is we need to graph this transformed function, or the function that's in white here. Okay, and so all we need to do is if numbers are on the outside of the parentheses, okay, if the numbers are on the outside of the parentheses, like 1, this is on the outside of the parentheses, and 2, these numbers affect y, okay? And if we have numbers on the inside, like pi, these numbers affect x. So the way we're going to think about this is to graph our transformed function, we're going to make another table, and we're going to have x and y. And all we need to do for the y's is you're basically replacing this guy with the y's that you started with in the original parent function. So how you're going to calculate your new y's is going to be by using 2 times your old y's plus 1. Okay, so this is going to be our new y's. So you take 0, you plug it into y, 2 times 0 plus 1. That's equal to 1. So for our new table, our y value, that first point, rather than being 0, is going to be 1. Okay, now we plug in 1, 2 times 1, that's 2, plus 1, 3. So now the point that was 1 before is now 3. Cool. So let's keep going. We'll plug in 0 again. We'll notice that's the same y value we had before, so nothing's going to change. This one's also going to be 1. Next, we're plugging in -1, so 2 times -1 plus 1. That's equal to -1. And then once again, we're plugging in 0, so we have 1. So our 5 points transformed from 0 to 1, 1 to 3, 0 to 1, -1 to -1, and 0 to 1. Okay? Okay, cool. So now we just need to do the x's. The x's work a little differently. You can't just plug it in where the original function is. To be able to find the x's, what we need to do is whatever's on the inside of the parentheses. So for instance, in this one, we have pi over x. We need to take pi x and set it equal to the x's that we had in our original graph. So for the first one, you're going to set pi x equal to 0 and solve. Divide by pi, that tells you x is equal to 0. So then our first x value, our pi x, is going to be 0. Okay? Now let's do the second one. You just take pi x again. You set it equal to our new x value. This time we have pi over 2. So you're going to set it over to pi over 2. And now we're going to solve for x. So we divide by pi. We get x is equal to pi over 2 divided by pi. Remember, you flip and multiply. This is just going to give you x is equal to 1/2. So I'm not going to show you how to do the algebra at this point. You should already know how to do that. So I'm just showing you the technique. We just pi x equals pi over 2, and we just try to get x by itself. That tells us our new x is 1/2. If you were to do that again, we set pi x now equal to our third x value. Pi x is equal to pi. Divide by both sides by pi. That tells you x is equal to 1. So there's our new x value. And then the next one is 3 pi over 2. You divide by pi. The pi's are going to cancel. You just get 3 over 2. So I'm going to erase some of the work here and then just show you that. So we had pi x. We set it equal to our old pi. This is 3 pi over 2. We divide both sides by pi. These pi's are going to cancel. That tells us x is equal to 3 over 2. And then for the last one, we want to use 2 pi. We're going to set x pi equal to 2 pi. Divide both sides by pi. Pi's cancel. X is equal to just 2. So now we have our new transformed sine graph. So all we need to do, we can even draw the picture relatively the same. It's just now, rather than using 0, pi over 2, pi, 3 pi over 2, and 2 pi as our x values, we're going to use 0, 1, sorry, forgot the 1/2. We're going to use 0, 1/2, 1, 3/2, and 2. And remember that 0 is part of it. So at x equals 0, our y value, rather than being 0 like it was here, it's going to be 1. So then we make a tick mark for 1. At 0, our first point is here. So I'll do that in the white marker. So that's our first point. That's this guy right here, 0, 1. Our next point is 1/2, 3. So we're going to need a couple more tick marks. 2, 3. And at 1/2, our sign value is going to be 3. The next one, the point 1, 1, 1, 1. Cool. 3/2, -1. So then we need to make another tick mark. Okay. So at 1 we have -1. Sorry, let's change the color. It's at 3/2. It's putting it in the wrong spot. 3/2, -1. And then our final point is 2, 1. So we go to 2 for x and then 1 for y. So there it is. And now we just connect the dots. We already know what sine should sort of look like. And so there is our graph of sine. Cool. It's not the prettiest picture, but it gets the idea across. I have my 5 points labeled, which is what you'll be expected to do on the exam, and my new table. Okay, so this is how you would graph a transformation of sine. All right, so let's do another one. So let's do f of x is equal to, let's do 3 cosine of pi x minus pi over 2 plus 3. Let's just do something like this. Okay, so luckily the table for cosine and sine is going to be the same. You're still going to use the poles from the unit circle. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And actually, the x values for this table will be the same for sine, cosine, secant, and cosecant. So we'll do one of those in the next one, and then we'll move on to tangent. But for now, our x's are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now we just have to think about the values of cosine. Well, cosine at 0 is 1, cosine at pi over 2 is 0, cosine of pi is -1, cosine of 3 pi over 2 is 0, cosine of 2 pi is 1. And so if we remember that the value of cosine kind of looks like a little toilet bowl, that's the way I look at it anyway. You can look at it however you choose to. We know that the maximum happens at 0. Then we go through the x-intercept at pi over 2, so this is pi over 2. We have a minimum at pi. We have another x-intercept at 3 pi over 2, and then we have a maximum at 2 pi. Okay, so now we just need to work on this graph right here. This is just the function f of x equals cosine of x, which is the parent function. Now we're going to try to graph the transformed version. So let's choose a different color. And so our table is going to kind of be the same. But remember, if the numbers are on the outside of the parentheses, they affect y. So the 3 and the cosine is the function, so it's going to be 3y plus 3. And then for whatever's on the inside, well, we have the pi x minus pi over 2. That's going to affect our x. Pi x minus pi over 2. Okay? So to figure out what our first y value is, we just take our old y value and we plug it into that guy. So it's going to be 3 times 1 plus 3. That's equal to 6. We plug in 0. 3 times 0 plus 3. That's equal to 3. 3 times -1 plus 3. That's equal to 0. 3 times 0. Well, we already did that one 2 lines above, so that's going to give us 3. And then 1 again, that's the first number we did, so we'll get 6. So our y values have changed from 1, 0, -1, 0, 1 to 6, 3, 0, 3, 6. Okay, now for our x values, the more complicated one, you take whatever you have on the inside of the parentheses, and then you set it equal to your old x value. So now I'm setting that equal to this guy. Now we just have to solve for x. So you add pi over 2 to both sides. You get pi x. Then you divide by pi. X will be equal to 1/2. So our new x value is 1/2. Okay. So let's do the next one. So our next x value is pi over 2. So we're going to add pi over 2 here. And solve for it, add pi over 2. 1/2 pi plus 1/2 pi is a whole pi. So pi x equals pi, divide by pi, x equals 1. Cool. And I'll do one more and then just fill in the rest of the table. So the next one is pi. So that's our third one right here. We're using this guy. So we add pi over 2. So we get pi x is equal to 3 pi over 2 by adding pi over 2 to both sides. This is what I'm doing in case you haven't caught on yet. Then we divide by pi, x is equal to 3/2. So now our new x value is 3/2. If we were to do the next one, with the same technique, you're just going to take pi x minus pi over 2 and set it equal to 3 pi over 2. Three pi over 2 plus pi over 2, adding pi over 2 to both sides. That gives you pi x is equal to 2 pi. Divide by pi, x is equal to 2. And then if we do it one more time, then we'll substitute for 2 pi, our final x value. We add pi over 2. That gives us 5 pi over 2. I'm doing that because, here, actually, let me slow down, show you. So add pi over 2 to both sides. Okay, so these add to 0, so we get pi x is equal to 2 pi plus pi over 2. We're adding fractions, we need common denominators, so we need to multiply to the bottom by 2, multiply to the top by 2. We get pi x is equal to 4 pi over 2 plus pi over 2. 4 pi plus pi is 5 pi over 2. Equal pi x, divided by pi, the pi's cancel, you just get 5/2. Cool. All right, so then there's our new table. So now we want to graph it. And so, going to do this in green. Here's my graph. I need to label my x's 1/2, 1, 3/2, 2, 5/2. So notice we're not using 0 anymore because we shifted a little bit. So we're going to start here. We'll call that 1/2. We'll call this 1, 3 pi over 2, 2, 5 pi over 2, or sorry, not 5 pi, just 5 over 2, or 2.5. You can use the decimal representation if you want. So at 1/2, so for this point, the ordered pair is 1/2 comma 6. So 1/2 for x, but 6 for y. So 1, 2, 3, 4, 5, 6. So then I'll plot it in white. So there's my point, 1/2 comma 6. The next point is 1 comma 3. So that's x1, y3. There we go. The next is, I threw a pi in there, that shouldn't be in there. 3/2 comma 0, so at x equals 3/2, y equals 0, so it's an x-intercept. X equals 2, that's all the way here, y is equal to 3, so we'll go up here. And then 5, at x equals 5/2, y is equal to 6, so we're going to be back at our maximum. And so this is kind of the way the graph looks. Cool. So there's the transformation. So this graph here is the graph f of x is equal to 3 times cosine of pi x minus pi over 2 plus 3. So there's that graph. Okay, so now we did sine and cosine. Let's kind of hang on to this table because what we're going to graph next is secant. So if I wanted to graph f of x is equal to 3 secant of pi x minus pi over 2 plus 3, and you're noticing that I'm using the same numbers that I did for cosine. It's because to graph secant and cosecant, you just graph sine. So what I would do if I was tasked with graphing this problem, I wouldn't graph secant. What I would do is I would graph it as if it was this guy. So you're not even going to worry about the fact that it says secant. You graph it as if it's cosine. And luckily, we have the table for that guy right here, the work we just did. So I'm going to go ahead and copy that. Okay. So So remember, this one is for cosine. So what you do is, I don't want to delete it. What I should do is put some arrows saying this is for this guy. And I'm going to also copy my graph. Okay, cool. So this was the graph that we just did for cosine with the same numbers here. And so if we plug in for secant, remember that secant is just 1 over cosine. So wherever you have a 0 for cosine, actually, let me go bring the original table back too. Okay, so the table on the left is the 3 cosine pi x minus pi over 2 plus 3. And the table on the right was just f of x. Let me change the colors and write a little neater. This one was just f of x equals cosine of x. So wherever on the original cosine graph, so it's going to be the second point here and the fourth point here, wherever you got 0 for cosine, the original cosine graph, so notice that these points, pi over 2, 0, changed into 1, 3 and 2, 3. That's this point right here and this point right there. Wherever you had 0 for cosine originally, those are going to turn into vertical asymptotes for cosecant. So we're going to do it with red. Kind of got the things backward here. Let me use a different color. Let's change the green one. Let's use a blue. So anywhere those points came from, 1, 3, and 2, 3, these are going to be vertical asymptotes. So we're going to draw our vertical asymptotes here. And then you'll notice for cosine, it's kind of like a happy face, right? It's got this kind of curve to it. For secant, that minimum is going to be a maximum. So you basically just point the arrows the opposite way, like that. And then notice how on the right side of 2, we kind of have this like r. It kind of looks like the lowercase r. Your graph for cosecant is going to start at this point, but it's just going to go the other way. And the same thing here. We kind of have this type of shape happening for cosine. We're going to start at this point and then just go the other way towards the asymptote. So just extend my asymptote so it becomes more obvious. You're basically drawing cosine, but then graphing the curves in a mirrored fashion. So now if I can go back and erase cosine like that, this is the graph of the original function for secant. So the way you graph secant and cosecant, so secant goes with cosine, cosecant goes with sine, is you graph it as if it was cosine, and anywhere that the original cosine graph output is 0, so these points right here that match with these guys, rather than having points there, that's where your vertical asymptotes are, because remember that secant and cosecant have undefined values at pi over 2 and 3 pi over 2 for cosecant, or for secant, and for pi and 2 pi and 0 for secant. Okay, so that's this one, and then let's do the same thing with the sine one. So we had 2 sine pi x plus 1. So if we had imagine we were trying to graph 2 secant of pi x plus 1. Well, what we would do is we wouldn't worry about graphing secant. What we're really going to try to graph is 2 sine of pi x plus 1 first. I'm going to use this as a base. And then, so this is going to be x sine of x. We're always going to need to start with the parent function. So 0, remember we're using the poles here, 0, pi over 2, pi, 3 pi over 2, 2 pi. Sine of 0, 0, sine of pi over 2, 1, sine of pi, 0, sine of 3 pi over 2, negative 1, sine of 2 pi, 0. And so notice sine, or secant, since sine has 3 zeros, it has 1, 2, 3 zeros, we're going to have 3 vertical asymptotes for our 1 period of sine. Okay? So we need to do the same thing to figure out what this graph looks like. So we need to create the table there. So why don't I do that in red? Let me change. So let's see. G of x is equal to 2 sine of pi x plus 1. Come back in, create our table. X 2 sine pi x, actually, hold on. Remember, if it's on the outside, it affects y, so the 2 and the 1, so 2y plus 1. And then our x is just pi x, whatever's on the inside of the parentheses. And we could go through this again, but why don't we just steal the values from our table that we did before. Save ourselves a little bit of work here. So here's our table values. We've already done the work. Might as well use the resource. So just going to fill this table in. So our points are 0, 1/2, 1, 3 over 2, and 2. And the other points are 1, 3, 1, negative 1, and 3. And so, cool, now I can erase this. So now to be able to graph, I'm still just focusing on sine. I'm going to graph sine. So our x values are 0, 1/2, 1, 3/2, 2. And our y values are 1, negative 1, and 3. So 1, 2, 3, negative 1. And now we just need to plot our points. So we have 0, 1. And I guess I will do this in a different color. Let's do green. So 0, 1, that's that point right there. 1/2, 3. That point, 1, 1. That point, 3/2, negative 1, that point, and 2, 3. Should it be 2, 3? No, that number's wrong. I must have copied it wrong. It should be 2, 1. Sorry, just didn't copy that point down right. 2, 1. So then this green thing is, this green graph is actually this guy. And now, but we want to graph the blue guy. So let's change our color to blue. So everywhere that we had a 0 for our sine function, so these 3 points, we're going to have vertical asymptotes. So 0, 1, it's not going to be a point, it's going to be a vertical asymptote. 1, comma 1. This is going to be a vertical asymptote. And then 2, comma 1 is going to be a vertical asymptote. So there's our vertical asymptotes. And then for the 3/2, comma 1, you see how it's kind of like a happy face going on over here? We're going to flip it and go the other way. We have a sad face here. Well, we're going to have a happy face here starting at this maximum point. So then that, like that. And now we can just erase our sine graph. So got rid of sine. And so there is secant. So that is the graph of 2 secant pi x plus 1. So the way to graph secant and cosecant really is just to go through everything as if you're graphing sine or cosine. And then wherever you had zeros for sine originally, you're going to have vertical asymptotes, and then you kind of flip the graph the other way. Okay, and then finally, let's do one more, and we'll do tangent. So, So let's say we want to graph f of x is equal to 3 tangent of, let's do pi over 4x plus 1. Just making up numbers. So for the original graph, we want x tangent of x. This is equal to y. You're not going to use the poles for tangent of x, at least not all of them. What you're going to use from the unit circle, I don't know why I drew that so large. You're actually going to use the angles 0, pi over 4, so the 45-degree angle, pi over 2, 3 pi over 4, and pi. And so the reason why we don't use the poles is because tangent and cotangent both have just a period of pi. So they start duplicating themselves once they've gone halfway around the circle. So we're going to mimic that in our table. So our x values are going to be 0, pi over 4, pi over 2, 3 pi over 4, and pi. And tangent of 0, that's 0. Tangent of pi over 4 is 1. Tangent of pi over 2 is undefined. So this is going to be a vertical asymptote for us. Tangent of 3 pi over 4, that's -1. And tangent of pi, that is going to be 0 for us as well. Okay? So then now, but this is just for regular tangent. We need to get our table for 3 tangent of pi over 4x plus 1. So if it's on the outside, it affects y. So we do 3y plus 1. And then over here we have pi over 4x. So for the y's, just like we did before, we're going to take this y, plug it in. 3 times 0 plus 1, that's equal to 1. 3 times 1 plus 1, that's equal to 4. 3 times undefined, so if it's undefined to begin with, it's undefined, so we don't have to worry about it. It's still going to be a vertical asymptote. 3 times -1 plus 1, that is equal to -2. And 3 times 0, we already did that one, it's equal to 1. So there's our y values. Now let's do our x values. We have pi over 4x. We set it equal to our first one, equal to 0. Divide by pi over 4x, that tells us x is 0. So there's our first x value. Now we move to our second. So pi over 4 is equal to, pi over 4x is equal to pi over 4. Divide by pi over 4, that tells us x is equal to 1. Okay. The next value, pi over 4 is equal to pi over 2. Divide by pi over 4, the pi's cancel. We get x is equal to 1/2. Excuse me, it's equal to 2. I guess if I made a mistake, I should show you the algebra for it. So we need to divide both sides by pi over 4 or multiply by 4 over pi, so that the pi's cancel and the 4's cancel. If we multiplied it on one side, we should multiply it to the other. So the pi's cancel, we're left with x is equal to 4 over 2, which is just 2. Cool. That's just telling us where the vertical asymptote is going to be. So let's set this up again. The next one, we're going to do pi over 4x is equal to, and 3 pi over 4. So now I'm using this guy. To get rid of pi over 4, we multiply by 4 over pi. The pi's cancel, the 4's cancel. If we multiply it to one side, we have to multiply it to the other. 4's cancel, pi's cancel, just leaves us with 3. We've got to do it one more time, so pi over 4x is equal to pi. Multiply by 4 over pi, multiply by 4 over pi. Pi is pi over 1, the pi's cancel, we're just left with 4. These cancel, so x is equal to 4. Cool. So now we have our table. We can get rid of this and sketch our graph of tangent. So our x values are going to be 0, 1, 2, 3, 4. Well, that's really nice because those are nice happy numbers. Let me zoom in. No reason not to. So you can probably tell I'm not going to be grading you on artistic ability, but more so that all of your work is shown or all that your points are labeled clearly. So our first point is 0, 1. So x equals 0, y equals 1. So we're going to need a 1. We have y's going up to 4, so we might as well put those guys in there. And then we have y's going down to -2, so we might as well do that. Okay, so our first point is 0, 1. So this is 0, 1. And I'll plot it in blue. 0, 1 is right here. And then our next point is 1, 4. So 1, 4. Cool. The next one is 2, undefined. So this is a vertical asymptote. Our next point is 3, -2. And the next one is 4, 1. And so the way that this is going to look is on this side you're going to have it going up like this towards the vertical asymptote up here, and then over here it's going to be coming down like that. And so if you wanted to draw the entire 2 periods, what's really happening on the other side is that there's actually another vertical asymptote here at -2, and it would be finishing like this, and just like here you would have your next asymptote at 6. So at 6 you'd have another vertical asymptote and the graph would finish like this. But luckily for you guys, I'm only asking for 1 period, so we don't really have to worry about any of that. So this is our sketch of 1 period of tangent of x. So this graph right here is that function there. So really what I'm looking for is 5 points and the work to get there. Obviously here I did a lot of work, such as pi over 4x equals to pi over 4, and I erased it. I mean, on your exam you're going to be showing that work and leaving it there. You don't necessarily have to show me all the algebra. You could just jump from here as x equals 1, and then, you know, plotting that point right there, but, or not right there, but there. I just want to see, at least to be able to follow most of the work that you guys have. Okay, well, so we've shown for the most part how to graph all of them. I guess we might as well do cotangent as well. It'll only be another 15 minutes, so let's do it. That way, in case it comes up, you've seen an example of how to do it, at least directly from me. Okay, I won't copy it then. So f of x is equal to 3 cotangent of, and let's do, let's just do pi over 4 again. Make this a 2, change things up a little bit. Yeah, why not? So for this guy, we're going to use the same. Remember, for cotangent and tangent, we're not using the poles, but we're going to be using these angles here, same ones as tangent. So we're going to use 0, pi over 4, pi over 2, 3 pi over 4, and pi. This is x, this is cotangent of x. Remember, we always got to do the parent function first. Cotangent of 0 is 0. Cotangent of pi over 4 is 1. Cotangent of pi over 2 is undefined. Actually, nope, I got that wrong. Hold on. Cotangent of 0 is undefined because this is cosine over sine. So this is undefined. Cotangent of pi over 4 is 1. Cotangent of pi over 2 is 0. Cotangent of 3 pi over 4 is -1. And cotangent of pi is undefined again. Okay, so that's the parent table. And now we need to do the table for the function in red. So for the x's, it's what's on the inside of the parentheses. We're just going to take pi over 4x. For the y's, it's what's on the outside, replacing cotangent with y. So it's going to be 3y plus 2. Take our y's, plug it in. 3 times undefined, it's always going to be undefined, so that's good. It's easy. 3 times 1 plus 2, that's 5. 3 times 0 plus 2, that's 2. 3 times -1 plus 2, that's -1, and then undefined, this is going to be undefined again. And then for the x's, we just take the pi over 4 and set it to our original x's. So for the first one, we're going to be setting it equal to 0, just like we did for all the others. Pi over 4x is equal to 0. Divide by pi over 4, that tells you x is 0. The next one, pi over 4x is equal to pi over 4, divide by pi over 4 on both sides, and that's x is equal to 1. Like I said, I'm erasing the work here. You guys won't be doing that. I'm just doing that to hopefully not make this lecture as boring as possible. So we want to get x by itself, so we want to get rid of the 4, so just multiply by the reciprocal. The pi's cancel, the 4's cancel. If we did it to one side, we got to do it to the other. Pi's cancel, 4 over 2, that's equal to 2. So there's our next point. Cool. Hopefully you're seeing the pattern here. Pi over 4x is equal to 3 pi over 4. Multiply by the reciprocal again. The pi's cancel, the 4's cancel. If we do it to one side, we got to do it to the other. The pi's cancel, the 4's cancel. Gives us 3. And the last one's just going to give us 4. It's going to be the same x values as the tangent one, luckily. Okay, and then now we want to graph it. So we come down here. Let's do it in green, just have a different color. Our x values go from 0 to 4, so 0, 1, 2, 3, 4, 1, 2, 3, 4. Our y values go from undefined, that's not really a number, from -1 to 5, so -1 all the way to +5, so 1, 2, 3, 4, 5. Okay, so then our first point is 0 undefined, so undefined, that tells us vertical asymptote. So graph it in the original color, which is red. So we have a vertical asymptote at 0. We have a vertical asymptote at 4. The next point we have is 1, 5. So 1, 5. We have a point here. At 2, we have 2. So 2, 2. That's this point is 2, 2. Hopefully It's making sense. I'm graphing that guy right there. The next point is 3 comma negative 1, so 3 comma negative 1. And now we just kind of connect the dots, and tangent and cotangent kind of look like x cubed and negative x cubed. So there's the graph of cotangent. So 2 vertical asymptotes and 3 points. So it's going to be the 5 points that we're looking for. And that's how you graph cotangent. So this graph right here is f of x is equal to 3 times cotangent of pi over 4 x plus 2. So I've shown you how to graph all 6 trig functions. If you have any questions, go ahead and let me know. Nobody asked any questions up to this point, but after grading the homework, I figured you guys may benefit from a different technique than the one that you guys saw. So if you have any questions, just let me know. You guys have until Sunday to take the exam, so if you're still feeling shaky, I would send me an email or get in contact with me through Canvas before you start taking your exam. Make sure you feel a little better about the graphing because it's quite a big portion of our second exam. All right, cool. I'll look out for your questions and just let me know. Thanks.